Okay. Welcome to join today's Velero community meeting. I think most of the members are working for testing case and preparing for RC of 1.14. That is overall status. And I see. So as so we will skip. So for the I see most members are working on the testing and the bug fix. So we will not go through for each and so Shubham, you have some detailed update, right?
Just two issues that you assigned me yesterday. I think I did a documentation PR for the volume policy extension feature, and I'll add more logs, I think, for the skipping criteria.
Okay.
Mhm.
Yeah. Any update? Status update besides the testing. If no, we can go to the discussion topics. So the first one for Daniel, please.
Yeah, just wanna communicate the date about RC1 in 1.14.0. So because we delayed a couple of weeks of the FC, so we want to target the RC date late in May. Because here I want to be transparent in Beijing team. We are also experiencing some reorg now. That's also part of the day two activity post Broadcom's acquisition. So there are some overhead here. So that may impact the progress of version 1.14.0. So I wish to propose we have more buffer about the development in Velero and release of Velero in 1.14.0. So do you have any concern targeting the RC date around the late of May? Okay, so it sounds we're okay with that. I'll update the wiki and I'll give you more update in the follow-up community meetings.
Okay. Okay. Thanks, Daniel. The next one, Scott, please.
Yes. So I did see there was yesterday a new comment posted with kind of some little more details on kind of some concerns from some of the maintainers. I do intend later this week to go through and because I'm actually going to in the middle of preparing a response to that kind of for each of the points. I think right now though we should probably step back a little bit instead of dealing with the details and maybe kind of talk at a higher level. I think there may be some of the back and forth. We may be missing some things in terms of use cases or requirements either way or concerns. So I figured maybe here we talk about this a bit at a higher level, and then depending on how that goes, then later in the week I can respond to the specific comment, possibly giving people, other maintainers, a chance to follow on to those recent comments first, if that makes sense. Okay. And I was just gonna I guess briefly mention a couple of things, kind of high level kind of reactions to kind of what I'm seeing with the discussion, and then from there maybe go to kind of if there's any questions to ask or whatever. I think the first thing that kind of stuck out to me, kind of looking at the alternate proposals, is that one of the things that we did in the most recent update was I reached out to some people internal to Red Hat, trying to get some better kind of thinking around, or some feedback on what kinds of use cases we need to deal with. Let's get a very concrete example. My thinking there is if we have a very concrete use case, then that's one criteria we can use to make sure that whatever design we eventually approve meets those requirements. And my last comment and kind of included that just briefly. This the case there was is a specific application, Cassandra operator, where you've got a replica set with 3 different pods. Each pod, not a replica set, sorry, a stateful set with 3 pods. Each pod has its own volume, and those pods really need to be backed up together so we could do some pre-hooks across all of them, back up all the volumes and post. So that kind of provides an example of the kind of use case that, this is a very specific use case, for a real application that users are trying to back up. I've actually seen issues put in the past around, trying to deal with that application. So that's something as we go through these, here's a use case we can make sure that if we look at, the various comments and the various, proposals, is this use case handled?
Yep. Yeah. So this for this central use case, it will be helpful only when we implement the group snapshots, right? Because
this is group snapshots. It is a way of doing this kind of thing, but we actually don't need group snapshots for this use case. All we need is the additional items. If you look at again, kind of offline after the meeting as well. If the application writer, or if the operator author wrote a plugin, for example, again, one of the proposals was, if we didn't extend backup item action, we might make a new plugin type. I think Daniel had suggested, where we would have this item block action that return additional items. They could write a plugin for this particular operator that said, for any pod in this operator, return the other pods as related items. And that would allow us to do this even without the volume group snapshots, because the volume group snapshots aren't yet production. So, customers that are in production clusters.
Without the group snapshot, even though, so here we have 3 pods, and we want to, when we back up the first pod, and we want to return the pod 2 as a related item or additional item. So even we do this without the group snapshot, or when we back up, let's say that when we back up time 0, T0, we back up pod 1, and then it returns pod 2. And so in T1, we visit pod 2. There are still some time lags, and the sample time or the data state is still not
that's where the hooks come in, because the point of hooks is to prepare the application so that it's not making changes to. So it might not be perfect, but if you run the pre-hooks for all 3 pods, and then you back up the pods, and then you run the post hook for all 3 pods, which is what would be, which if the design as proposed would do that, because one of the parts of that design is for an item block, if there are multiple pods in that block, we run all the pre-hooks first before we back up any of them, and then we run the post hooks at the end. So that provides that. So if, for example, if you did an FS freeze for all 3 pods, that would happen before we backed anything up.
But first of all, we need to run the hooks one by one. So pod 1, pod 2, pod 1, pod 2, and pod 3. So since the hooks are associated to the pods, so when we run the hooks, I believe that the hook is to tell the concerned Sandra to freeze the IO or freeze the IO, right? So there's still some time lag. If we talk about application consistent, there's still some time lags. So maybe at T1, at T0, we run a hook for pod 1, and T1 we run hook for pod 2,
I mean,
right?
You can't guarantee the hooks are run at the same time, but what we do guarantee is all the hooks run before we start backing up any of the volumes. I think that's probably sufficient for any real use case, because I don't think there is a solution that guarantees that all the hooks are run exactly the same time for a bunch of pods. I don't think you can do that in any backup solution.
Yeah, that's one thing. So strictly.
Wait, hold on. Do we agree with Scott? What Scott just said, that is sufficient for a backup solution, and that the item blocks, as we are proposing, does solve that problem?
That depends. That depends what kind of consistency do we want to achieve. If we talk about the application consistency, this is not enough. And if we talk about to make the consistent better for some special application like or complex application like Conceptra, I think it helps. But that is for pod 1, I think help. But I also want to say point 2. right? For point 2, that is something like when we only run the hooks, it doesn't. It may not help in the for the final consistency because we run the hook, we tell the application to freeze the I/O, but we don't tell the file system to freeze the I/O because application cease writing doesn't mean that the file system cease writing. So we still need to take the snapshot together if we want to achieve better consistency.
I don't disagree. You're right. Once we have volume
Wait,
group
hold on,
snapshots
hold on.
as an option.
Scott,
Yeah,
hold on.
sure.
I'm trying to understand something. So it sounds like your problem, if I understand point 2, is that while the hooks solve some problems, they may not solve all. And to solve all problems, you would need some way to run some command inside of the container to freeze the file system. And
no.
Actually, not to seize the file system. It is to take snapshot together at the same time, exactly the same time. That is why we need a group snapshot.
Yeah, we don't disagree on that. The group snapshots will come when they're available, and this solution will also resolve that use case. But in the absence of those, this gets us closer.
So come back to my original question. So I think this without the group snapshot, it may help the consistent for some application in some way, but we don't achieve any better or outstanding improvement for the consistent. Like currently we are correct.
I think we're dovetailing too hard. Let's take a step back.
Yeah.
So the goal here is that we would like for operator authors to be able to back up their stuff in a way that makes sense for them. Whether this
so it's a very to me it's like a vague description. What is sorry, I forgot the word. So what is something like
that's a vague description, right? That's what you want to say.
When we talk about the data protection, we say crash consistent, file system consistent, application consistent. So that is standard way we talk about the consistent. So sorry, I forgot the word, but I think you have said that the backup operator or the application writer can use this better or something like that. But when we talk about the data protection, we only have 3 standards, right? That is, I'm not sure.
I think what I heard, and let's make sure that I'm understanding. You're saying that from your perspective, the only thing that matters is the data consistency.
Yeah, I think here when we talk about this special case like for consent, right, I think this is about the consistency.
Sorry, I didn't understand the last bit. Can you repeat that?
Sorry. When we talk about the first case, the current case we are talking about for Cassandra, I think we are talking about the consistency.
Yeah, I think we need to Cassandra is an example. It is not the only case. So I'm worried that we are focusing too much on individual details and not looking at the bigger picture. And the bigger picture here is that we have lots of different operators who manage things in lots of different ways. Whether that be they have their own pods that they're managing, whether they have their own, their own external resources, all kinds of stuff, right?
Yeah.
And what we would like to be able to do is say, hey, if you have a dependency chain of how things need to go, it'd be really great if you would write a plugin, and then we can actually respect that. And this would allow the authors to be able to do stuff that would actually be useful to the system. So let's take a step back and let's not rabbit hole on one particular problem, but instead let's talk about what this enables for the users and why it would be useful to them.
The
reason I included that example wasn't because solving this example is the only thing we need to do. The reason I mentioned the example is because this is an example that must be solved here. So we need to make sure that whatever solution we come at a minimum solves this. But to Sean's point, this is just an example. If you have other applications as examples, things that you need to, those can be included. If we ideally we'd have a list of several examples that the requirements must meet.
Please go ahead.
Yeah, go ahead then.
Yeah, I want to point out two things. First, I think the example of Cassandra explains why we sometimes need to execute a group of, the hooks of a group of pods together. I think that explains this case, but this case is not very different from any regular case where in future we need a group volume snapshot. So again,
I think the problem here is that we're talking about volume snapshot.
Yeah, exactly.
So
And volume group snapshots is another use case that we need to solve here.
Right.
But I want to point out that these two cases are essentially one case where we want to execute hooks for different pods together first, snapshot or backup the volume, then execute the post hook. I want to point out that's the same case.
That's an important point. And I think they're one case in the sense of what Velero needs to do. The way they differ is the way that Velero understands them, because the volume group snapshots is a function of, obviously the volume groups, but a given application that has similar needs may not use those, especially if they're in a cluster that doesn't support them yet.
So the concept item block action, item block, what does it mean? I think
So
you just want a group of pods.
Well, they're a group of items. They include pods, but they also include PVCs and PVs. They might include config maps in some cases.
Custom resources.
Yeah, the example to solve the specific use case of item group snapshots means that the item block needs to include multiple pods, multiple PVCs, and multiple PVs. So that's one example. But you might have other examples where they have custom resources or big maps or other secrets.
I'm not very convinced, or maybe I haven't think too much about this problem, but I don't see any case like you want to group CRs in one group. Because
for instance, the SED operator, it actually manages the pods by itself, and it can have ephemeral volumes. And in that case, you would want to back those up this way. There's cases around probably cross-plane resources when you need to back those up all in one. Let's say like you're going to back up some S3 buckets or something. There's cases around what's some other good ones? There's some networking stuff that you would do during an operator. That an operator would do that you would want to manage with hooks as well as then with pods. So you would want to do those in a special way that would not be related to a volume snapshot, but would be related to the actual hook.
But again, here you just want to group pods together to execute hooks.
No, I don't.
Right? We want to group items together. I think pods is way too specific and doesn't solve all the use cases.
We're missing each other.
I just try to understand why grouping pods together.
So in those cases, what you would want to do is you would want to group up the things that the operator is working on, basically. So for a given CR, you would probably want okay, this has this set of networking stuff. I need to go turn that off, back up that networking thing, back up all of the stuff that's related to that, and then continue on.
So when you say turn that off, how do you do that? Isn't that through executing hooks?
Yeah, you would. The only way to implement this right now in Velero is a pod hook. But if you give them the ability to do this, then it actually is useful in the larger case of the entire operator, not just in that given pod, because there's more than one pod. There's lots of things going on there.
Yeah, let me add something from the higher level, and I think we just mentioned that there are many cases we want to solve for with the current PR, like the consistent things or the timing things or something. Many cases, and I actually I think the concerns from the concerns is something like we are not very convenient. Oh, sorry, we are not very convinced that this design could solve how many the cases could this design could solve, and what are the cases exactly, and how this design solve the cases. So I have a proposal, like we just take out one case and we discuss this in detail, like what we have discussed for Cassandra. But if we want to do it for Cassandra, we change another case. We just find one case we discussed in detail. We prove that the current design could solve that case, and then we get to another case, and finally we will be able to all of us will be able to believe that okay, the design could solve many cases.
I have a question. So are you saying that you don't believe that the current design would solve the Cassandra case?
Yeah. So for the Cassandra case that I just mentioned, I think it is mostly about data consistent case. So
that's
when we talk about
that's a different statement. That's a different statement, right? It would solve the problem that we are bringing up, which is that you would want to run the hooks for all of the pods at a given time. The current design would solve that problem. Would it solve the
okay? So why do we need?
Hold on.
Okay.
The underlying problem that you're bringing up now is a shifting of the goalposts, which is now it doesn't solve this other use case that we didn't bring up, that we are not solving, that is only solvable by volume group snapshots, that therefore we shouldn't do this. I think that's a slippery slope.
Sorry, I didn't get your last.
I'm saying that when we're talking about this, it would solve the problem of being able to run those hooks all in one go. It would solve the problem of getting us a step closer to what we want. Then you say, but it doesn't solve this other problem, which can only with volume snapshot groups, because that's the only layer that would be able to solve that. Therefore, we shouldn't do this. And I'm pushing back. Well, that's a shifting of the goalposts. This does solve the problem.
Yeah. But what about we talked about this in this way? So we first point out what kind of problem is solved for Cassandra, and then we send this to other cases. Like what is the basic case we have or problem we have solved for Cassandra? I think I just mentioned we have run the hooks for the pod together. So what is that? What does it solve? What problem?
Right. So part of it, as you mentioned, is you get the hooks run together, and the way we solve that is we provided a mechanism to identify related items. So in the Cassandra case, the related items in question, at a minimum, would be those three pods and their PVCs and their PVs. The pod to PVC and the PVC to PV is a relationship that we need for any pod that has data. But the Cassandra case just adds to that by now joining, say, these three pods together, and the item group, the item block action plugin suggestion, solves that by allowing the Cassandra authors to identify those pod relationships, so that when we're backing up one of those pods, they're able to say, based on the characteristics of the data, also include these other two pods. And to Sean's point about eventually solving the volume group snapshots, the same design, the same ability to identify, once you have that item block action in place, when we go and implement item block support, not item block, volume group snapshot support in Velero in a future release, That very same API can be used to identify the pods that need to be backed up together because they're connected to that volume group snapshot.
Yeah, for this point, I totally agree that this the current design is very helpful for the group snapshot, but I have to say that without the group snapshot, the current design doesn't solve or doesn't the current design doesn't help in the conceptual case. So that is my point. So if we say in this way, we want to make a design and to prepare for the group snapshot, I will agree that. But I don't think
no, I disagree.
Something like yeah.
I disagree. It does help. How does it not? How does it not help?
I mean, I think it does everything we need except for the volume group snapshot, which we can't do yet. You get the hooks together, you group these together in a single worker so that they're done sequentially and they're not stepping on each other. Which was
for
the
that
intended
part.
goal.
Yeah. So I think we have two steps. So first of all, we have the current design or workflow change, backup workflow change, and then we have group snapshot, and then it will have concern draw. But without group snapshot, only with the current workflow change, I just don't know what its case has been or what problem has been solved.
Hold on. Today, somebody correct me if I'm wrong. My understanding is that in the Cassandra case, what would happen is that pod 1 would be backed up, its hook would run, its data would be backed up, then pod 2 hook would run, it would be backed up, the hook would, like the post hook would run, then pod 3 would be hook would run, then it would be backed up, then it would, and the whole time you're way worse in terms of data consistency, right? We would agree on that?
Because they're happening. Because the hooks are happening at very different times. So
the current design could give a better data consistency than what we have at present. But the current design doesn't achieve.
Yeah, I agree. And that's the point, is that volume group snapshots are not going to exist for some period of time. They're not going to exist for all CSI drivers. They're not going to exist for a lot of users in a lot of use cases. And we can make things better for people by doing this. So I'm
and they'll never exist for FS backup, for example.
But we still have to say that we are crash consistent.
I think that it's it would be. I don't think anyone is arguing that the current design would replace the need for volume group snapshots, if that's what you're suggesting. I don't think anyone has suggested that.
Okay.
I think what we're suggesting is that this does get us closer to helping those users that won't have access to those things and that will never have access to those things based on their CSI driver or whatever else. We do get us closer, and that is a worthwhile goal to make things better.
It also gets us closer because then when we implement volume group snapshot support, that will use the same API, new API. So we've done some of the work that we need later for volume group snapshots.
So yeah, I agree that this design or this code change will be very helpful for us to implement group snapshot later. That I will totally agree. But without the group snapshot, we can only say that we run the hooks for the related pod very close to each other. But for that we can. What we have done, we have stopped the I/O very close to each other, and we have we have take the snapshot very close to each other, but it's still not. We are running the hooks at the same time, and we take snapshot at the same time. That is different.
Yeah. That is true. But the other thing that I think is possibly even more important than the hooks running close to each other is also the hooks all run and complete before we start doing any snapshots. Then we do those 3 snapshots, or however many pods you have, and then we do the post hooks. So again, we're getting as close as we can to consistency in the absence of volume group snapshots, which I think is worthwhile, as a goal, to do, because we can't do any volume group snapshot cases today. And because even when they're available, We won't be able to do them in some cases because the driver won't support it. In other cases, because they're on a version of Kubernetes that's too old. And in another case, they're not using CSI. So those are cases where this helps even when they could never use the volume group snapshots. And the other thing I think is that, again, the reason we have plugins in Velero in the first place is because we can't implement every use case for user specific. We can't even know what they are. So, just like for the rest, we have for backup item action v1, for example, we have this plugin API. A lot of Velero's internal manipulations of data and backup use that API, pod action and PVC action and all those. But we use that same API for end users. And for example, in OpenShift for OADP, we create our own plugins that do things to OpenShift specific resources that would not be appropriate to include in Velero, upstream. And if there's a user of OADP or of any other version of Velero, if they're using some custom application that needs its own plugin for backup item action, even which is changing the metadata, they can implement that. And this would provide this new plugin type we're talking about would allow the same kind of thing around these interdependencies of resources. If you have an application, for example, that modifies a config map as part of its, what it does, you're going to want that as part of the pod for maybe, and then you have your hook that shuts it down. So it stops modifying the config map, and the config map gets backed up along with the pod. So that's a hypothetical example. No, it's not a real world example. I don't know of a specific application that does that. But the whole point of this kind of pluggable API is to say we have, a certain number of use cases that we can identify specifically and say, these internal use cases, these external use cases we know about are handled by this API change. But we also want to design the API in a generic way because we know that someone's going to write an application tomorrow that has a new connection that we didn't know about. Well, they can write a plugin to handle that using the same API because the whole point was to make it generic enough to say, hey, I'm backing up an item. I know this other item needs to be in the same, backed up at the same time as this. Include that.
I think part of the gap of understanding is in the different understanding about item blocks. I think internally we just think one case that you put different pods in a block and execute hook together. If we can have a more clear definition of the item block instead of saying, hey, different items in one block can be backed up together, can we have a more clearer definition about that? For example, if I put different types of items in one block, how will Velero handle that? For example, if I put a pod and a config map in one block,
okay.
how does that solve any problem? I'm a little confused.
Let's start with this. Well, let's start with a specific example that we know must belong in the same item block. If I have a pod that has a volume mounted via PVC, I know that PVC has to be in the same block as that pod, because otherwise, otherwise your hooks and your snapshotting are going to be out of order.
If I understand
So I understand. I think I misunderstood. So my mistake. So different items in one block have to be backed up in a sequential way, right? And we can back up different blocks concurrently.
Yeah, exactly. That's exactly the way this works. So if we look at the existing pod action and PVC action in Velero, where right now, we're not putting pods together, but we're treating pods as separate things that have their own volumes. If I have a pod that has a PVC and a PV, we know that we need to run the pre-hooks on the pod before we snapshot that PVC, and then we run the post hooks after we snapshot that PVC. So that pod and that PVC must be in the same item block, because once we go to having these multiple blocks in parallel, so here's an example where it would definitely break down on you. If you have a small backup, just a single pod and PVC and PV in it. If that PVC and that pod were in separate item blocks, we would, go through first item block is the pod, send it to a worker. Second group is the PVC, send it to a worker. At that point, they're in parallel. They could go in any order. So you could conceivably start snapshotting that volume in the second thread before the first thread runs the prehooks. So that's an example of why even different item types, object types, might need to be in the same block. So we need this pod and the PVC and the PV in the same item block. Once we add multiple pods together, that group of pods and all of its PVCs, their PVCs and PVs need to be in that block. So the config map example, and again, I can't tell you an application that does this, but if you imagine you write an application that keeps some of its live state in a config map in the cluster rather than in a mounted volume. If that were the case, you would want to run the prehooks on that pod before you backed up the config map that it was managing. So if you had a plugin in action that returned that config map saying, hey, this config map is part of the same group, same block, then you would get that behavior of the prehooks running and then the pod, the config map operating and the post hooks. So again, that's kind of an abstract example. The more concrete examples, some degree have to go back to the pods because those are the actual examples that we see with current Velero backups.
I think there's probably a bunch of CR examples that would do something similar to this, just as a heads up.
Yeah. Also, I think if we had hooks on other types other than pods, I think this would be a whole lot more important. Right now we don't, so we can kind of ignore that. But if Velero were ever to add the ability to have hooks on other resources other than pods, I think these item block groupings then become a lot more important.
So I'm not sure if I understand correct or not, but I think here we are talking about the cases that the currently the design could help to back up some applications that need to special taken care, like need to associate to group some items together. So the application or can write a BIA so that we to tell Velero to group the items together. That is for the current case. And actually here we have mentioned the other cases like users one. There is not any. The users just want to group some items together. Just for example, for performance improvement, like they have many items, and they want to group every 100 items together. So are we going to support this user provided grouping?
I don't think that kind of use case really makes sense into what we're talking about here, because we're talking about data consistency use cases of things that belong to each other. If a user says, "Hey, I want to run 100 items and together," that's the way a user would do that would be by manipulating the number of workers in the pool by setting, I want to have a pool of, I want to have 100 workers, or I want to have 10 workers, I want to have 2 workers, and so I can back up as many or as few things in parallel as makes sense. That's where the user would be involved.
I actually have a question on that particular point. If you scroll down, so it says 100 items which have no relationship with each other. Those wouldn't go in one block though, right? Because one block would be handling synchronously. So it would actually be slower to do it this way. Whereas
for example, we have many 2 million of the items, and when we have 10 work groups and 10 thread pool and a task thread in the thread pool, and for each thread or work item we process 100 items. That is something we think that this current design or the work group could help on the performance improvement.
If those items were handling asynchronously, I would agree with you. Is that what we're saying? You would want 100 items to be run asynchronously?
No, we have more than 100 items.
Okay,
Yeah,
I think I understand what you're asking here. Let me see. Let me try to rephrase it to make sure I got it right. So let's say you have a very simple but large backup of, I'm backing up 10,000 secrets and that's it. The basic approach of this design, and let's say we have 10 workers. The worker pool size is 10. So the way this design would work currently, if we implement it as written, each of those 10 workers would get one item at a time, up to 10,000, whatever. And each time it finished, it would return. So one item at a time. And I think the suggestion here is, if we have that many items, let's send 100 at a time to the worker pool so that you're spending less time, sending messages. I don't think that's,
Not only that, actually, we send 100 items to work item 1 and send the other 100 to work item 2.
Right, exactly. You're right. So in other words, if you have 10,000 items, and 10 in your worker pool size is 10, with if you don't have any groupings, then your channel is going to get 10,000 individual items being sent in, one at a time. The worker grabs it, backs it up, responds, gives a status back. And I think the proposal here is, what if I want to build up, send, instead of sending 10,000 small, items on the channel, I want to send 100 larger messages with 100 items in each one. And so I think if you, in an implementation with a very high thread overhead, you might gain something here. I suspect you're not going to gain much doing that here, but
we can still control the number of threads, like by the number of a work group item.
Yeah,
right?
Exactly.
So we have 10, and we only have 10 work group. Item. So each worker will need to handle 100 item for once, and the other one handle 100 item, and the other one 100 item. And anyone who complete, we have it handle the other 100.
So in that environment, instead, because in the original, if you don't have them grouped, then each worker grabs a item block off the channel, has one item in it, it processes it and returns. And the suggestion here, the block it grabs has 100 items in it, which it runs through sequentially and returns.
But the other 100 is run in parallel.
Right. You have 10 running in parallel, grabbing 100 at a time, versus 10 running in parallel, grabbing a smaller thing at a time. You're still backing up 10 items at a time. At most.
Yeah. So this is only one case that why user just group something irrelevant to one another.
I'm not convinced that the user would want to do that, or we would want to allow the user to do that, because I don't know that it's going to actually help us. I mean, I don't know, Sean, do you have any thoughts on this?
Something. Yeah, some cases we want to make clear. We understand that we want to solve some consistent problem, either from by the group snapshot or for the volumes, or by or just grouping the resources or Kubernetes resources to make better consistent. That we are clear. I'm clear. But we still think that when we go to the performance improvement, we may have some other cases like the one I just mentioned. So the question is whether we want to support that or not.
I think if we can back up for a second, I don't know if what you're suggesting would get you anything.
But I think based on the discussion, it seems like we should rethink the goal for item block, because currently the title says it's for backup performance. But
Yeah,
more and
yeah,
more,
that's
we are saying we are introducing item block for dependency.
Well,
And,
well,
Well, I
it-
think
the,
it
the reason it's
enables-
performance is because
well,
we're adding
yeah.
the worker pools.
yeah,
It's
but yeah, it's reasonable for everything worker pool. But we need to talk about the from end to end, right? I think I have one example of the case that we talk about end to end. That but I'm not sure if we want to support that, and I'm not sure if that is a valid case that we want to support.
Yeah, I think the case where you want to group a bunch of things together that are unrelated in order to make the fewer messages back and forth to the worker pools, that sounds like a kind of an optimization that you wouldn't make at the item at the level of the plugin, but at the level of saying, you know, I want
Item collector.
you know, I want to modify the worker model to say, instead of passing in one item block, I pass in a slice of item blocks, and then configure your application to say, I want to do 10 at a time or 5 at a time. I mean, if you need that kind of, you know, if you can demonstrate that helps performance, you can do that. I think trying to mix that up into the same API where we need to really, you know, because the only purpose of the additional items API change we're proposing in here is for identifying related things that must go together. I think if we have an optional notion of, you know, if we determine that it's going to be more efficient to process 10, you know, to have each worker thread grabbed 10 item blocks to process sequentially, and then grab another 10 sequentially, that's different.
If I can back up a second, the reason why we need item blocks before we move to a worker thread is because you can't have two things that are are dependent on each other in two different threads.
Yeah.
So you have to group the things. Yeah. So like that's the reason why item blocks is important to then move to the performance use case, which is the worker pool.
Yeah. To me, the item block is the minimum group of things that must go together. If we choose later to make bigger groups for each worker thread, like, you know, the idea here of, if we decide that it's actually faster to do 100 items at a time per thread, that's fine. But those are multiple item blocks that you group together. That's a different grouping. That's a performance-based grouping, not a data integrity-based grouping. That's probably a slice of item blocks that you pass down into the channel.
But I think there's an issue here. You cannot treat every block the same, right? Because in some cases, you want to make sure there are 5 blocks. They must be handled concurrently.
I think that's the definition of an item block, is the things that must be done concurrently. That's my point. That
wait, hold on.
Wait,
hold on. I want to make sure. Inside of an item block, all of the things that are in that item block must be handled synchronously.
Right, yeah,
and very special, and must be handled in a way that is like special cased, to use it, right? Where we make sure that run the pods first, we do this, we do that. We have logic that goes into the item block processing that is for handling all of the items that are in an item block. On top of that, then each item block is in parallel
with another item block.
But supposedly if we have 1,000 item block, we cannot handle these 1,000 item blocks in parallel, right? We need to.
That's the reason you have a worker. That's why you have a pool, because they're not handled.
Yeah,
right. You have a shared channel.
Let me. Maybe I misunderstood, but bear with me. Let me try to give you an example. For example, we have 10 item blocks, but 5 of them belong to the Cassandra example. So 5 of the blocks have to be handled in parallel together, right?
No. I think this is the misunderstanding. All of those things that are related to Cassandra must be in one item block. And handled synchronously.
Right. Also, nothing in the item blocks requires parallel operation, because our first phase is going to implement item blocks with no parallel operation. I mean, the definition of an item block is a group of things that are related to each other, and so they need to be done as a group, and therefore they can't be sent to different threads.
And I still have some question about what we have just mentioned. We want to minimize the user is about to take only the correlated items. So my question is, if we just want to do that, we will not be able to support the performance improvement for a larger scale. Like I just have many items. They don't have any relationships. But I just want to back up them in parallel. We cannot achieve that.
Well,
but-
no, you get that, because if you have multiple item blocks, if they're in different item blocks, by definition, they're going in parallel up to the number of workers you have. Because
yeah, from yeah, that is something.
so if you have if you have 100
trying to-
workers, you can do 100 items, separate item blocks in
Yeah.
parallel.
Yeah, so in detail, from the backend or worker item group level, I think we support that, but we didn't make clear of the entire case from end to end. Like how do we support user to group items into one block for the items that don't have relationships, and
They shouldn't.
we run.
There's no need to put them in one block, because you want them to be able to be done in parallel. So if they're not in a block, then the Velero has flexibility to put them in parallel. Whereas if you put them in one block, they have to be in one worker done sequentially.
So yeah, so if for the item block, we only allow related item, how to achieve the use case that I want to back up items without any relationship and in parallel from end to end.
Yeah, if you want them in
Hold on,
parallel,
let's
you don't
back
want
up.
them in the same item block.
Yeah, hold on.
Yeah.
Let's make sure I understand what you're asking. And let's make
Mm.
sure that that I'm answering the question that you're asking.
Okay.
The question I think you're asking is, I have 1,000 secrets. These secrets are not related to anything. I want to back
Yeah.
each one of those secrets up asynchronously.
Yeah. Not each of them. Maybe a group of them and asynchronously with the other group of them. It's a common.
I think that you're going to want to do each one async. I don't think that you're going to want to group them up.
If we do it for each one, I think I'm afraid we will have lots of threads.
Oh, we have a thread. The thread pool is limited in size. The user configures the size, the number of threads.
Yes, user can configure that. So from the work group level, we support that. But from item block level, we don't support that.
Well, no, because the thing is that the purpose of the worker thread is to process one item block at a time, which means if you have 100 threads in the pool. Yep.
Can you what is an item block to you right now?
Okay. So I think first of all, the item group could help to solve some data consistent problem in some degree. That part I understand. And the other thing is like, since we have worker groups, or generally speaking, we have some thread pools, and we have some buffers. That is for this thread pool to consume. So fundamentally, it will be very close to the requirement of the user case that I have just mentioned. I want each thread pool to handle or to process some of the item and for this thread pool to work together, so that the total throughput has been improved dramatically. The question is whether we support that or not in the current design.
Yeah, I think the answer is yes.
Yeah.
I think the answer is
yes.
yes.
Okay.
Yep.
Okay.
Okay.
If the answer is yes.
Yeah. The way that it does that is because for each one of those other items, those unrelated items, they would all go into their own block, go into the queue, and as workers become available, they would pull them off. Therefore, handling them all asynchronously.
Yeah. So one way of thinking about this is the thread size is constant. That's a server going to be a server param. Say you have 20 threads. Okay, you configure that in Velero server. So there's 20 threads waiting for item blocks. What Velero does in the backup controller is it goes through and generates the list of item blocks, and then it adds them to the channel. all 20 of
Okay,
these
wait a
threads.
minute.
Yep.
Sorry, just sorry
Yep.
of break.
Yep, go
Wait
ahead.
a minute. So here we have say that we the Velero need to generate some item blocks, but as we just mentioned, the item block doesn't allow on items without any relationships
Right.
into
No.
the item block.
Oh.
So that is
Yep.
my
Okay.
Okay,
Yeah,
so
in this example, you have item
no, I
blocks
think
with
it's
one
very
item.
simple. I think it's a very simple answer.
Mm.
The item block contains one or more items. When it
Yep.
Yeah.
contains more items, those items
Mm.
are related and will be handled in that synchronous way.
Right.
When it's
Sorry,
just one
sorry.
item, it will be
Yeah.
just that singular item that gets backed up.
Right. So in this example with 1,000 secrets, each secret is an item block of 1. You have 20 workers waiting to process those secrets. So when Velero iterates over the item collector output, it gets a list of item blocks all size 1. We have this channel that the Velero is putting all these item blocks in the channel until it blocks when the buffer gets full. Meanwhile, these worker threads are grabbing off one item block at a time. So 20 of them grab the first item block, or the first 20 item blocks. They back up the secret, return it, and then grab the next one. So 20 are being backed up at a time.
Okay, now I understand that we want to so take a secret, for example, we want to each secret in one item block, and but there is only one item, the item block, and the other secret in the other item block. But since we have 10 work groups, so we still handle 10 at a time.
Yes.
Asynchronously. That is
That's right.
yes.
Right, that is correct. And then just to show how this fits into the other case we talked about with pods and PVCs, just say for example, I have a namespace with a single pod in it and a volume and a bunch of secrets. So that pod and the PVC and the PV get grouped into one item block. So the first item block has 3 items in it: pod, a PVC, and a PV. The second one's a secret. The third one's a secret. So that first 10 item blocks that get backed up in parallel, the first block contains a pod, a PVC, and a PV, and that does the hooks, all the the volume and the snapshot and all that. Numbers 2 through 9 just have a secret. Those are going to finish quickly. So while the snapshot's still happening, threads 2 through 9 or 2 through 10 will get the next secret and the next secret and the next secret. And during the 10 seconds or so it takes to kick off the CSI snapshot, they might have processed 100 secrets each, and the other 9, once the pod is done and the PVC in that block, then that first thread is able to start backing up the secrets as well.
Okay, that is also the reason why we need to know the items in each item block beforehand, before we run it, the backup.
Or at least before, we need to know the items in a block before that item block gets added to the queue. We don't necessarily have to process the entire item block list from beginning to end, as long as we generate an item block, that any item that we add to the block gets removed. So in other words, we'll never process it. So in that pod PVC example, that first item block is going to have the pod, the PVC, and the PV. Then as we iterate over the item collector list, we get to the PVCs eventually. Well, we're going to recognize this PVC is already in an item block, so we're not going to add it to another one, so it gets skipped. So, so in other words, we don't have to calculate the entire list of item blocks for the entire list before we back anything up. But what we do have to do is, for any given item block, know its contents before we send that to the worker pool. And that's why we need some kind of API function that we can call before we get to the backup item action execute, which only happens, as we're backing things up. That's why, even if it's not added to backup item action, if we do as Daniel has suggested, creating this item block action, and actually, as we've been talking about this, I'm actually starting to think the item block action might be less confusing for plugin writers to understand purpose.
Yeah, I think that's a really good idea too, by the way. +1 on that.
So in other words, instead of BIA v3, we create a completely different, as Daniel suggested, a completely different API plugin type. Item block action is just as a possible name for it, which has that additional items, get additional items. So in other words, instead of adding a new function to BIA, we create a new plugin type that takes the same inputs and returns the same response, but it's a different plugin API. So hopefully, that might be less confusing for users.
Yeah, but before we discuss how we generate item block, I still want to clarify the concept of item block. So it sounds like we put items in one item block, and these items have to be handled synchronously. So by synchronously, you mean we handle them one by one, right?
Oh, synchronously within the block, I would say. In other words, it's still going to be async from the point of Velero's backup processing. If the item collector's output, we go through and process blocks. Each block goes into the worker pool. In other words, so this item block is going to be processed by a worker pool thread. But within that block, they're synchronous.
But I still want to clarify the concept of item block, because let's think there's only one item block, there's only one worker, and
well, that's a different.
Yeah, I think let's back up. Let's back up real fast. Are you thinking that for each item block, there's going to be a thread pool for that block?
No. I'm thinking there's a thread pool, and there's a multiple item block, and you handle them one by one. And there's a idle worker, you use that worker to handle that item block. I think I understand the idea, and but within this item block, things handle sequentially.
Yes, exactly. Within an item block,
but then that's not the same as a Cassandra example, because in the Cassandra example, you put different pods in one item block, and you handle these pods in a little bit different way. You execute the hooks, pre-hooks together, then you do something, then you execute the post-hook. So it seems that
but there's no threads in that.
Yeah, so I think the difference here would be, I think the question, if I understand correctly, the question is,
there are different tiers, right? The
I think what you're saying,
item block. So that's why I'm still.
I think if I understand it correctly, you're saying, hey, currently synchronous means that we back up one pod, then pod 2, then pod 3.
Yes.
And I think what we're saying is that item block, the item block worker, or the worker that's actually doing the work for a given item block, would have slightly different logic to handle the case where there's more than one pod in it. To run those hooks first, then do everything synchronously. So back up pod 1, pod 2, pod 3, PVC, whatever, however it does, and then run the post hooks for pod 1, 2, and 3 after everything's done.
That's right. And Sean, that's actually in the design, but I quickly describe, but the way I'm kind of seeing it is this. Right now, we have one function that we call backup item, and then the way backup item works is it runs the free hooks if it's a pod, then it backs up the pod, and then it runs the post hooks. So as proposed in this PR, we're adding a new function called backup item block. And what backup item block does is, first of all, it iterates over the list of items in the pod. If there's items in the block, if any of those are pods, we run the post hooks on the pods now. In other words, we remove the hook handling from backup item, and we bring it up one level to backup item block. So backup item block runs pre-hooks for all the pods in the item block. Then it calls backup item sequentially for every item in the block, which no longer calls hooks. And then after we've done backing up all the items in the item block, we then run post hooks. And if the block does not contain any pods, then obviously we skip the hooks just like we do now for backup items. So what we're doing is we're moving the hook handling up one level to backup item block. Handle that.
But like Sean just mentioned, I think, are we combining different tiers of things all together? Do we need to do that? Because I don't
think it's tiers. I think we're grouping items. It's in the concept of item block is just a group of items.
Yeah, but then when they are pods, then they become very different. But when they are regular stuff,
that's true, but that's also true in today's code. In the current Velero code base, we treat pods differently. We run hooks on pods before and after backing up, and we don't do that if it's not a pod. We're just moving the hook handling to the item block level from the item level. We're not. We don't have different kinds of item blocks, but we only run hooks if there's pods. Just like in current Velero in 1.14, we only run hooks if it's a pod. We're just moving that up to the block level from the item level. That's the only change to hooks, because backup, because basically at its,
but
if you
what
think about it without hooks,
but what if they are CRs? If the only special case,
yeah, if they're
CRs,
they're just another resource. I mean, the way I'm thinking about this is that, so an item block has a list of items. If we ignore hooks for the moment, backup item block as a function just iterates over the list of items and calls backup item in turn for each one. The next change to handle hooks is to, since we're now calling backup item from backup item block always, we just move the hook handling up one level in the call stack to backup item block.
Yeah,
So if an item block has one pod in it, the workflow is identical to the way it is today in terms of hooks.
Just
I
a quick
still think we need a different concept. But it's just my feeling. I think we need a different. Yeah, please go ahead.
Yeah, let's walk through. You said you were mentioning something about what if it's a CR in the item block. And my question was to be, what do you think? Like, what is the problem with that?
Yeah, because you mentioned that there are some special case similar to pod. Because what I'm struggling with is why we need a very generic logic to handle the very special case in which is the pods. Then you mentioned there may be some problem around CRs, but then it seems we can only handle pods differently in an item block. I mean,
so I think I think I understand the question. I think your question is, hey, one of the things that we talked about with needing this like more generic way to group the items is that there's other resources that need to get all together. You mentioned that CRs like will have like some special stuff in them or magic.
No, I think my concern is I'm still not very convinced. Like we need a very generic way to generate item block. I think part of the reason is that we try to combine different things in one concept. We try to combine the pod, hook, execution, orchestration stuff in item block, but at the same time, we want to improve the performance via item block. We are trying to combine too many different things in one concept, and that's why.
Actually, the item block concept is pretty simple. It's just a list of items that are related to each other. That's all there is. That's all it means.
Hold on one second, Scott. I'll say one thing, which is that I actually think that you need to have some concept like item block to even increase performance. Right?
Yes, but then you also mentioned that we need that concept for dependency.
So then the dependency part here is just a way for other users to be able to make sure that their application is backed up safely.
Yeah.
So we're doing that special logic for so for instance, right, like right now the only tool that I have as an end user is to write a pod hook, right? As an application operator author, the only tool that I have in my toolbox is to write a pod hook that would make it so that one pod was backed up safely. That's the only tool in my toolbox. We're talking about adding the ability for that more than one pod to be able to go together for lots of reasons. But we're talking about it. And the goal here is, hey, it seems really easy to help those users by making a generic way that we'll end up using too. So it's just easy to use. It's going to be the same thing. It's going to be probably a lot less complicated code. It's going to be one thing, and will enable end users to be able to do this same thing.
Yeah.
So you might not be wrong that we are adding two things in this one design, but they kind of all tie together in one bigger concept.
So,
Yeah.
let me try to give an example of, I think, conceptually what an item block is, and in a non-code example. So something totally unrelated to Velero or even software to kind of communicate what I think an item block means. This might not be helpful. It might be, we'll see. But basically, think of it as an idea of, you have a crowd of people, and they have to get somewhere. You have, people by themselves, you have families together, you have couples. In one example, let's say you're renting cars. Well, you want to put, the families together in the same car. So you don't end up with like splitting families apart in different vehicles or whatever. But say you want to increase your performance and, charter some buses. Well, that's fine. You can put a bunch of them together, but you still want to keep those groups together. So the item block concept says these people belong together, keep them together in a group. But if you want to increase performance by saying, hey, I want to, just like in Velero, the suggestion was, hey, let's back up 100 items at a time. I want to have larger, transport. Here's a bus that holds 50 people.
But I think
so the item block is still the family, the group.
Yeah, but let's continue with your example. What if the bus is big enough that I can put different families? How can we tell that?
I mean, exactly.
But then in your item block, we what if we put 10 pods together, but 5 of them belong to one group? Then that's not possible, right?
So the item block in the bus example is still the 10 families that are in there. They're grouped together. So these 2 people, these 4 people, these 6 people, are in groups, and you fit them so they can fit in the bus, but you don't split them up. And so in the item block case, if you want to take, if you want to, if for example, we do decide that somehow it's more efficient to have fewer things processed at like larger chunks processed at one time in a thread. I don't know that there's any value in that, but if there was, which is was the proposal here, I would not propose making a big item block with 10 pods that were unrelated and calling that an item block. If you wanted to pass larger groups to a worker pool at once, you would not just combine unrelated blocks together to make a big block. You would create a list of blocks and pass that. You would still keep the item block separate, because the item block concept says this is a minimum size of things that must go together. This is where we run the hooks, because you don't want to run those hooks before all 10 pods if they're unrelated. So the item block as a concept specifically says these things relate to each other. They need to be backed up sequentially in a single worker at the same time. And any pods in this block need to have the hooks run before and after. If we want to group those blocks into larger lists of blocks at a future time, if we think that's going to increase performance, we can do that. But we're not going to shove them together and say this is one big item block. We're going to create a higher level concept of a list of item blocks if we need to. I don't know that we need to. I think that's a future enhancement to this design. I think that we can add later if we see value to it.
Let me share my understanding here. Just in one word, like we are using the item block to solve the dependency problem, to solve the consistent problem, and we are using the worker group to solve the performance or to parallelism problem. So here I have one quick question. I'm not sure if that is we need some evaluation. Maybe not sure if it's a problem or not. This when we solve the concurrency problem, and if items are not related to each other, we have to wrap item block to each of the items. Say we have 10,000 of items, we will need to wrap 10,000 of item block, and each item block has only one item. That brings some overhead. So
I think that overhead is negligible at best.
Yeah. So it's okay. it, by that I didn't, just a question. If you think that is we can ignore that.
Yeah, I think you'd
it's
have
okay.
to prove that a go struct with a slice of pointers would be enough overhead to warrant changing, or I don't even know how else you would do it, I guess the question would be, but like that's what you're suggesting, right? Is that a go struct with pointers would be enough memory overhead to invalidate the design?
No, actually, not only pointers, but we have also a structure called item block, right? So we will have one more item block structure.
Yeah. Yeah, I
Yeah,
mean,
that's what I'm talking
basically,
about. That's struct
yeah.
with a
So
bunch of pointers.
the item block struct include, you know, the bulk of the item block is the item list. The other elements in the item block struct are other inputs that are needed to pass to backup item. So, you know, the fact that you have, in other words, 10,000 item blocks of size 1 versus, you know, 1,000 item blocks with 10 items in each one. I mean, the amount of the other thing is that the larger item blocks you make, that means you're having more of those in memory. I mean, I think it's, as Sean said, it's probably, this is going to be negligible. You know, it's pretty normal in Kubernetes to have slice types that are normally have one item in them, but to handle the possibility of, you know, maybe having additional ones, even though they almost always have one item in them.
Okay, I'm not sure it's a problem or not. I just bring some, you know, so that we can notification so that we can evaluate if necessary.
So it seems that by default, we should put one item in one block, except for the case when you want to execute hooks of a part, different parts together.
I would say there is no by default. The reason we have this new API plugin type we're creating is to generate those item blocks. So if I have an item and there is no an item block action plugin registered, for example, then I only have one item because I have no way of getting other ones. If there is a plugin registered, then I call the method on it. And again, if I get back a list, those get added to the block and called recursively. If the list is empty, there's not really a notion of a default item block. The idea is for every item returned from the item collector, we construct the item block. And if there are no dependencies found, either because we don't have any plugins registered or internal items registered, actions registered to give us dependencies, or we do have those registered, but they return. So for example, you know, we would have an item block action equivalent to pod action. And that pod action would return a PVC. So when we called it on the pod, we get the PVC. We call it on the PVC, we get the PV. Now we have an item block with a pod, a PVC, and a PV in it. On the other hand, if we're backing up a secret, there's probably not going to be an item block action registered for that responds to secret. So we have nothing to call. So we have no choice but to have an item block with just one item in it.
So is it possible that we for the workgroup item or for the thread pool, it can process raw items without item block or together without item block? So like I will push item blocks and also raw items into the buffer.
So
is that possible?
So you still need a struct because there are other inputs to the backup item. If you look at the other field, the only difference would be, again, you have a slice with one item in it versus an item that's not a slice. I think the amount of memory taken up by the difference, I mean, there's going to be very little difference there. You know, you have a community resource.
What's the goal of doing it that way in your mind? Like what would be the benefit?
I'm not sure. I just thinking about the problem.
We are coming back and forth because we are combining different concepts together. Sometimes we talk about item block, sometimes we talk about what the worker should handle, right?
So item block, I mean, the concepts are totally separate. The concept of item block has nothing to do at all to do with the worker, because the item block just says these things are related to each other. In fact, the first phase of this is going to implement item blocks and all of that without creating a single worker thread. It's all totally synchronous. And it's only a second phase where we then split up the item backups and make it asynchronous using the worker threads. If there were no associations, relations between items ever, and PVCs were always backed up totally separate from the pods, then we wouldn't need an item block concept. We would have a
yeah. I thought we need that. I'm just thinking about if we allow the work group to handle the raw item at the same time together with the item block, we may be able to first for the memory or for the overhead problem we have discussed a little bit, but we can.
Yeah, I mean the overhead is literally the difference between the difference between a slice with one item in it and the item.
Correct.
Yeah, and the other thing is like we may be able to decouple things. Like for now we can, for the first phase, like we can implement the item block, for example, and the item block could handle implement the work group, and the work group could handle item block and raw items, and later in the further releases we just implement the item block.
No, I think we have to implement
things.
item block. No, we have to implement the item block first.
Because without the item blocks, you're putting these in parallel, and you're going to break
right
workflow.
Right.
Yeah. Okay. Okay. I'll see the first thing about that.
But yeah, if you go back and look at the design, though, that's why I split it into phase 1 and phase 2. Phase 1 has no work groups added, no multi-threaded. It's just focusing on the model changes around item block and the plugin. And right now,
what I'm thinking about is like we just create a work group and we just push the raw items to the work group, and we can still solve the concurrency problem. Right,
no, I think that's.
You can't because the PVCs are going to break break down. That's why the order was item blocks first, and then the concurrency second.
Yes, correct.
Yeah, I understand. Okay, yeah. Okay, I think we have we have done a very good discussion about the current design and.
But in terms of how to generate the item block and how we handle them, I think I'm not sure how Yonghui has been doing, but I don't think I fully understand that. But okay. I think this discussion helps me a lot to understand the idea behind that. The item block can be, they have different phases and
one thing that I will do. As we've discussed this for the last couple of weeks, I think it's become clear to me that I think it's easier to understand and simpler to implement if we split out and make this item block kind of dependency thing a separate plugin type rather than backup item action v3. I will go later. I need to update the design to reflect that. I think it might be easier to see because right now I mentioned that as a alternatives considered section at the end. But I'm thinking if I go ahead and put that in line, that might make it a little bit simpler to see, because then we have a single new plugin type with a single, function added to it that basically says, additional items, get additional items, or get. Maybe should we actually? I'm just thinking. I should probably call it get. What do you think, Sean? Calling it get related items rather than get additional items might make this clear in the API.
Yeah, I mean, naming is the second
I was using additional items because that's what it's called in BIA, but this is a new plugin type. Yeah. We're not limited to backup item action, terminology here. If I call it get related items, that might make it clear what the intent is.
Yeah, I think so. I think Yeah. So if it sounds like we all kind of have a better understanding now of where we're at, or what we were talking about. Do any of the questions that you guys asked in this comment that's on the screen still relevant after talking this through? Or do we need to answer one of these questions more directly now that we've kind of talked about this?
Actually, I have a very detailed question, but I think maybe you have think about that, but I don't see that in the design. Like, how do we generate, like Daniel said, how do we generate item block?
So that is Yeah, I mean, so that's the thing I was just talking about just now, that I do need to modify in the design. The design actually does call out exactly how we do that. In the design, we're talking about using the new method added to backup item action v3, and instead, I think we're replacing that with the idea of basically we need a new plugin type called item block action, which will have a, so like all the other plugins, we have an applies to method, which, so this applies to all pods, has some criteria to know which items it matches to. And then we would have the get related items, which you pass in the backup and the item content. And in return, in response, the plugin action would return that list of items. So for example, we would need a pod action for this new plugin type that would take in the backup in the pod, and it would look at the PVC, the volume list, get the PVC, return that PVC as the related item. PVC action would then return the PV, and the end result is now we have a pod and a PVC and a PV together.
Yeah, and here it's a question like the item collection, it's grouped by alphabet order. So
yeah,
how do we solve the
Okay, yeah, and that's actually a good question. Again, I actually was kind of trying to prepare a response to this comment. At this point, I'm not sure it still makes sense to respond directly, just because we talked through some of these, but I could just go ahead and, for context, do that. But I can talk now a little bit to that. So I think
Scott, it is getting late. So it is getting late. Like we're a half hour over. So I don't know if if you guys are, if everyone's getting tired, I just wanted to take
Okay, this is only a detailed question. I think
that is a good question actually, and I think short answer is we can handle it in the plugin if we have to temporarily. The longer answer is we may want to introduce something like the restore resource priority list on the backup side.
I think that there's probably something there for us to dig into. Is there another question that you guys are still have open that you want answered? I assume that also as you guys talk internally, I'm assuming more questions will come up now that we've kind of level set a little bit. I'm sure. So I'm just trying to maybe make it go a little faster. If you have them written down already.
That makes sense. So basically, if you want to comment on the PR with any additional questions, my thinking now is over the rest of this week, I'm going to go and modify the design a little bit in response to some of what we talked about around the plugin stuff. And then I could go and directly answer this comment. Some of this we've, I think, answered in the meeting. Some of we haven't. So if you want to modify the comment based on what we talked about in the meeting,
I'm kind of wondering if maybe
say 2 days from now, I can respond to whatever's there. Because as I said, I was actually ready to respond to this already, but I figured let's have the discussion first, because some of the questions will get answered here. We have new questions.
So I think, another option I think would be if you guys could just repost another comment with all the questions that came up from the meeting, and that way we can respond to those. And if it's just a copy paste of that one, that would be really helpful.
Yeah, that makes sense. So if there's anything here that's still a question as is, include it. If some of these questions are answered, don't include those. And if you need to modify the question to make, because I think we do need to kind of continue on that path. And while you're doing that, I will go and modify the design itself to deal with the plugin changes that I know of that I need to make. And then later in this week, I can respond to any updated comments.
And I'm hoping that this was like a helpful discussion where we all are better at understanding where things are at. And I think I understand a lot more of the concerns that you guys were talking about. I hope I've addressed them. So thank you guys for the chat.
Yes. Yeah. Thank you for your time. And we will further discuss and modify our comment to leave the questions. We think that is open, and so that you can further check that.
Perfect. That's awesome.
Okay.
Sorry, Scott. I just I know we're a half hour over. I wanted to I wouldn't want to hold everybody up, and also I want to watch my hockey team play. So yeah.
Okay.
Enjoy.
I think we have done our current discussion, right? So no further question, we can finish the meeting here. And thanks for time. We have run our time. And yeah, we will see you next 2 weeks.
Yeah, thanks everybody. This has
Thank
been
you.
really helpful.
Yeah, sure. Thanks. Bye.
Thank you.
Thank
Bye.
you.
Thank you.
Bye bye.
You